Okay, to draw a box plot you need lowest value, Q1, median, Q3, and the highest value. They each correspond to one part of a box plot. This is what the basic box plot looks like. Something to that effect. You, of course, when you draw yours, will draw it much more accurate than mine. And these all correspond to these lines. Now, I'm pretty sure you guys can draw a box plot, given if you can find those values, which we worked out in the last video, you can line them up on an axis like that, where this is X and you have values all the way along here. Alright, so that's pretty straightforward. But the important thing that I want to talk about is when you're dealing with box plots, each section is worth 25% of your data. Okay, so each section is worth 25% of our data. The middle, the box part, is worth 50%. 25 plus 25. Okay, so that's the most important thing for you to remember with box plots. There's been quite a few exam questions where they've asked you roughly what percentage of people have gone through here and roughly what percentage of people are up to there. Alright, and that's what they're talking about. There is one other concern when you're dealing with box plots, and that's outliers. And this is where you need to be able to work out the interquartile range. You need the interquartile range to work out if a value is an outlier or not. So, if we had a data set that was, let's go to 15, 17, 18, 19, 20, 25. So let's call that our data set. Okay? You can see 2 is, I'm hoping, I haven't tested this, I'm hoping 2 is an outlier. So if we go through and do our calculations, 1, 2, 3, 4, 5, 6, 7, so my median is there, that's Q1, and that's Q3, lowest value and highest value. So I've got my 5 numbers and I'll write them out for you. So lowest value is 2, Q1 is 15, median is 18, Q3 is 20, and highest value is 25. So if I were to just take them, stop moving the page, if I were to just take them and draw them on an axis, there we go, there's my scale. So that's 26. So if I were to just draw that, I would be doing something like this. Where that would be my box and whisker plot. However, if I do this calculation for work out whether something is an outlier, because this whisker looks far, far, far too big. So if I do a calculation, there is a calculation you can do. If I think this is an outlier and it's below, I do 1.5 times IQR, okay, and I do Q1 minus that. Okay, so the lowest quartile minus that value. And if this value falls below that number I get, then it is an outlier, and I need to treat it as such. So we're going to do that calculation now. So my interquartile range is 5. If I do 20 minus 15, my IQR is 5. So Q1 minus 1.5 times 5. Oh, Q1 is 15. So 15 minus 7.5 means that it's 7.5. Anything less than 7.5 is therefore deemed an outlier. So what do? Do I do that as an outlier and then come to 7.5 here? Ooh, and then draw my box, like so? The easy answer is no, you do not do that. You use your data points. You use the values in your data. So for this particular example, the next data point is 15. So what I do is I draw my outlier down there at 2, and for this one, this is going to be an odd-shaped box plot. Oop, that's supposed to go there. There is no bottom whisker here because the next value is 15. If I had a value in there that was 13, then I would go to that value of 13 there like that. If a value is less than Q1 minus 1.5 times the IQR. Okay, so that value there. Or if it is greater than Q3 plus 1.5 times IQR.